Welcome back to the deep dive. If you've been moving through the world lately feeling, I don't know, a little on edge,
hmm
maybe like the ambient room temperature of your psychological state is just running a few degrees too hot,
I think a lot of people can relate to that.
you are definitely not the only one. Today we're starting with a bit of a reality check, but I promise we are going to end up somewhere incredibly practical.
That's right. And to be honest, reality check might be putting it mildly. We're looking at a global context right now where anxiety isn't just a personal quirk or, a fleeting feeling before a presentation.
No.
It has become a statistical tidal wave.
I was reading the intro to the first stack of research we're covering today, and the numbers are just staggering. Since that massive global shift in 2020, we have seen the prevalence of anxiety disorders jump by an estimated 25.6%.
A quarter, a 25% increase. In the world of epidemiology, that is absolutely massive. It's not a blip, it's a trend line.
And it really feels like we're all walking around with this low-level hum of fight or flight just running in the background apps of our brains.
We are, and in the literature, there's a term for this. We refer to it as allostatic overload.
Allostatic overload. Okay, break that down for me.
So everyone knows homeostasis, right? It means balance. Your body wants to stay in a stable state.
Right.
Allostasis is the process of achieving that stability through change. So like your heart rate goes up when you run, then it comes back down when you stop. That's allostasis. It's adaptive.
It's the system working correctly.
Exactly. But allostatic overload is the wear and tear on the body and brain when that stress response is constantly activated and never fully turns off. It's when the system gets stuck in the on position.
That feels like the defining condition of modern life. It's not just one big tiger chasing us, it's 1,000 little gnats. Notifications, emails, news tickers, the economy.
Exactly. And the problem is, when we are in that state of overload, we often feel, well, helpless. We look at the external world, which, we can't control, and we feel like our nervous system is doing things to us.
It's happening to me. I'm just along for the ride.
Right. But the whole mission of today's deep dive is to flip that script. We want to look at the internal control panels.
Okay. So we are going to pop the hood on the human nervous system. We are doing a deep dive into the biology of calm. And to do that, we have pulled two really fascinating heavy-hitting stacks of research.
We have, and what I love about these two sources is that they cover two very different levers we can pull. They almost feel like they shouldn't go together, but when you overlay them, the picture is just incredible.
So set the scene for us. What are we working with? What's the first one?
Okay, so the first stack is behavioral and mechanical. It's a massive systematic review titled Breathing Practices for Stress and Anxiety Reduction. When I say massive, I mean they started by screening over 2,900 articles.
2,900. That is a significant amount of data sifting. That's not just a weekend project.
No, not at all. They effectively audited the entire field of breathwork to find out what actually works scientifically and what's just, noise.
In the second stack.
The second stack takes us from the lungs deep into the brain. It's a molecular neuroscience review. This one focuses on oxytocin.
Ah, the famous love hormone, the cuddle chemical.
We'll hold that thought, because as we are going to find out, calling it the love hormone is actually a pretty dangerous misunderstanding.
Yeah.
It's much more like a pay attention hormone or maybe a salience modulator, and understanding that distinction explains why, in some cases, this chemical can actually make anxiety worse.
Okay, that sounds like a paradox we definitely need to unpack. So we have a mechanical lever, the breath, and a chemical lever, oxytocin.
And our goal is to see how they connect. How do they work together to lower that allostatic load we were talking about?
Let's start with the breath, because I think everyone listening has been told at some point in their life, usually when they're freaking out, to just take a deep breath. It's almost a cliche.
It is.
But the systematic review suggests it's not quite that simple.
It's not, and that's why the study is so valuable. It's not just a list of things that work. It's an audit of the components. They looked at 72 specific interventions across 58 high-quality clinical trials.
And just to clarify for the listener, when we say high quality, we mean these weren't just like online surveys asking, do you feel better?
Correct. No, these were studies using validated psychometric tools, things like the STI, which is the State Trait Anxiety Inventory, or the Beck Anxiety Inventory.
So real metrics.
Right. They were looking for statistically significant reductions in stress scores. Hard data.
Okay, so what was the batting average? Out of those 72 interventions, how many worked?
54. 54 of the 72 were deemed effective.
That's about a 75% success rate. That's pretty solid.
It is solid, but as scientists, or at least as people obsessed with optimization, we are actually more interested in the 18 that miss.
The failure.
The failures. Because if 54 worked, that means 18 failed. And by looking at why they failed, we can build a framework for what actually drives the biology of calm. It's reverse engineering success from failure.
This is the cheat sheet we promised. So let's look at these exclusionary components, the things that kill the effectiveness of breathwork. What is the #1 way to mess this up?
Speed. The data is just crystal clear on this. Fast breathing in isolation generally fails to reduce stress.
Now, define fast for us. We're talking about like full-on panting.
Technically, the review flags anything over about 20 breaths per minute. If you look at the studies where participants just did fast breathing, like a rapid rhythmic breath without any slow component, it simply didn't work to lower those anxiety scores.
Which, if we think about the physiology, makes perfect sense, doesn't it?
It does. I mean, think about what your body does when you are running from a threat.
You're hyperventilating.
Right. You breathe fast and shallow to oxygenate the muscles for fight or flight.
So if I'm sitting in my office chair breathing 30 times a minute, I'm basically hacking my system in the wrong direction. I'm telling my brain there's a tiger in the room.
Precisely. You are upregulating the sympathetic nervous system. You are hitting the gas pedal on stress. Now, I do want to add a nuance here because there are popular techniques that use fast breathing.
Right, I was going to ask about that, like Wim Hof or Tumo breathing, or even just some vigorous yoga breathing.
Exactly. And the review acknowledges this. Fast breathing can be effective, but only, and this is the absolute key, only if it is paired with a slow phase or some kind of breath retention.
Ah, okay. So it's about the contrast.
It's all about the contrast. There was a study, Bulban, in 2023, which is discussed in our source stack. They looked at what's called cyclic hyperventilation with retention.
Cool.
So you breathe fast to charge up the system, maybe creating a little bit of stress or alertness, but then you exhale and hold. Or you slow it way, way down.
So the fast part is the stressor, and the slow part is the recovery. And it's the cycle that's beneficial.
You got it. That cycle can be beneficial. But the fast breathing alone, that's just telling your body to panic.
Okay, so rule #1 in the framework.
Right.
If you want calm, you have to slow it down. What's rule #2? What's the next big mistake?
This one is called the 5-minute rule. And honestly, this is the one that gets the most pushback from people who are busy.
I can already tell I'm going to hate this rule. I want the 30-second fix.
We all do. We want the hack. But the data from the review showed that session duration is a critical variable. Interventions that use sessions shorter than 5 minutes consistently showed poor results.
So let's paint a picture. I'm in traffic, someone cuts me off, I feel the road rage bubbling up, I grip the steering wheel and take 3 deep breaths. Does that do nothing?
I mean, it's better than screaming.
Sure.
It might stop you from rear-ending the guy. But in terms of shifting your baseline state, in terms of measurable psychometric stress reduction that persists after you start breathing, the data says no.
Why is that? Why is 5 minutes the magic number? Is it arbitrary?
It likely comes down to physiological inertia.
No.
Think of your nervous system like a freight train. If that train is barreling down the tracks at 100 miles an hour, that's your high anxiety state. You can't just tap the brakes for 10 seconds and expect it to stop.
You have to hold the brakes down.
Exactly. You need sustained signaling. You need to send the safety signal via the vagus nerve for long enough that the neurochemistry actually shifts. The norepinephrine needs to clear out of your system. The acetylcholine needs to uptake. It's a biological process, not a light switch.
That is a really practical, if somewhat inconvenient takeaway. You can't just dabble. You have to commit to that block of time.
Right. It's a dose-response relationship. And the minimum effective dose, according to this massive review, seems to be about 5 minutes.
Okay, so we know what not to do. Don't go too fast and don't make it too short. Now let's flip it. What about the core components? What did the 54 effective studies all have in common?
The biggest one, and this might surprise some people who prefer to just, figure it out on their own, is human-guided training.
So I need a teacher.
Yeah.
Like in person.
At least for the first session. The data suggests that interventions where the initial learning phase was guided, and this could be a person in the room, a video, or an audio guide, were significantly more effective than purely self-taught or unguided methods.
Why do you think that is? Is it just that we're bad at following written instructions? Like trying to assemble IKEA furniture for our nervous system?
That's part of it. If you're trying to learn diaphragmatic breathing from a pamphlet, you might interpret it wrong. You might be pushing your belly out with your muscles rather than actually relaxing the diaphragm. A guide provides cues, they correct you.
But I feel like there's something psychological there, too.
Yeah.
More than just the mechanics.
Absolutely. Think about the concept of cognitive load. If I am anxious, my brain is already spinning. My prefrontal cortex is offline. If you tell me to sit down and do a 4-7-8 breathing pattern, now I have to count 1, 2, 3, 4, hold 1, 2. No. I'm monitoring myself. I'm the project manager of my own relaxation.
Right. You're working. You're adding a task instead of removing one.
You're using executive function. But if I turn on an app or listen to a guide on YouTube, I can offload that responsibility. I surrender the counting to the voice. I just have to follow orders.
It's permission to stop thinking.
Exactly. And that surrender allows the nervous system to drop into a parasympathetic state much, much faster.
That makes total sense.
Mm-hmm.
So use a guide, at least at first. What else was a core component?
The other big one is just consistency, multiple sessions, and long-term practice. The effectiveness correlates strongly with doing it more than once. The review defined long-term as 6 or more sessions over a week or more.
So it's a practice, not a pill. You have to train the system. It's like going to the gym for your nervous system.
Precisely. You're building a new neural pathway, a new habit for self-regulation. And that brings us to the myth-busting section of the review, which I found absolutely fascinating.
Okay, I love a good myth busting.
We have this cultural image of breathwork, right? You need to be in a pristine yoga studio, wearing linen, with incense burning, and perfect silence.
The whole wellness industrial complex aesthetic, yeah.
Exactly.
Yeah.
But the data says none of that actually matters for the biological effect.
Really, none of it.
The setting didn't matter. The effective studies took place in yoga studios, yes, but they also took place in university classrooms, in hospital beds, and even in dental offices.
Dental offices, that's primal fear territory.
It is, and get this, even in burn units. There was a study by Abo El-Ada in 2021 dealing with burn patients during dressing changes.
Oh my God, that has to be one of the most painful, high-stress experiences a human can possibly endure.
It is excruciating. High stress, high pain. And yet, guided relaxation breathing was shown to be effective in reducing anxiety in that specific context.
That is incredibly empowering. Because if it works in a burn unit during a dressing change, it can definitely work in my living room while my kids are screaming over a video game.
Exactly. You don't need the perfect environment. You carry the mechanism with you.
What about the population? Does it only work for, healthy 20-somethings?
Another myth busted. It worked equally well for youth, healthy adults, high anxiety populations, and clinical patients. No significant difference.
And what about doing it in a group versus by yourself?
No difference. The delivery method group versus individual sessions showed no significant difference in effectiveness either.
Okay, so this is stripping away all the excuses. It doesn't matter where you are, who you are, or if you're alone.
Right. Now, what about this specific technique? I feel like there are holy wars on social media about whether box breathing is better than coherence breathing or the 4-7-8 method.
Oh yeah, everyone has their favorite.
This is the other huge myth the review busts. The data implies that the specific mechanics mattered far less than the general principles.
So the brand name doesn't matter.
It doesn't. Whether it was 6 breaths per minute or 4 breaths per minute or deep diaphragmatic breathing or focusing on an extended exhale, the differences in outcome were negligible.
So what's the common thread? What's the active ingredient then?
The active ingredient isn't the specific ratio. The active ingredient is simply the slow, regulated expansion and contraction of the diaphragm. That's the signal.
That is so liberating. It means you can't really mess it up as long as you are slowing down and being consistent.
Precisely. However, we do need to talk about the outliers. Because there were a few studies that followed the rules. They were slow, they were guided, they were long enough, but they still failed. And the reasons why they failed are crucial for understanding the whole picture.
This is the detective work. What went wrong?
One major factor was physical discomfort. There was a study by Meyer in 2020. They took young, healthy adults, the ideal demographic for this stuff, and had them do a guided relaxation breathing practice for 30 minutes.
30 minutes is a long time. That should have been a deep dive into Zen.
You would think, but the protocol required them to do it while standing still.
Standing still for 30 minutes. Without moving at all.
Yes, and if you've ever tried to stand perfectly still for that long, you know it's not relaxing. It creates postural strain. Your stabilizer muscles are firing constantly. Your blood is pooling in your legs. It's actually stressful.
So the physical stress of the position completely overrode the potential benefit of the breath.
Exactly. The study found no significant reduction in stress. You cannot relax the mind if you are straining the body. It's a foundational principle.
That seems like a dumb moment in retrospect, but how often do we try to force relaxation in uncomfortable situations, like trying to meditate on a crowded bus?
All the time. Here's another example. A failed study involving patients undergoing a stereotactic breast biopsy. This was Ratcliffe 2019.
Okay, another high anxiety situation.
Extremely. But look at the mechanics of the procedure. The patient is lying face down on a table with their breast isolated through an opening.
Oh, wow.
Their chest and abdomen are compressed against the surface of the table.
And you're asking them to do deep diaphragmatic breathing.
Right. Take a deep belly breath. I can't. There is a table inside my stomach.
So the mechanical restriction blocked the signal. The message couldn't get through.
You got it. If the diaphragm cannot descend, the vagus nerve doesn't get the proper stimulation. The calm down signal never gets sent to the brain.
So comfort matters. The physical mechanics matter. What else?
The final caveat is technical difficulty. And this brings us to a specific technique. Alternate nostril breathing, or ANB.
Oh, I've tried this in yoga. You use the thumb and ring finger to block nostrils in a specific sequence. It feels a bit like a game of Twister for your face.
It can be very effective if you know how to do it. But there was a study, Kamath, in 2017 with medical students who were total novices. They tried to use ANB to lower their stress before a big public speaking task.
Yeah.
It failed. It didn't reduce their anxiety at all. And the hypothesis is that the cognitive load of the technique was just too high for them.
They were thinking, not breathing.
Exactly. They were so worried about, wait, is it my left nostril, now the right? Is it the ring finger or the pinky? That they couldn't actually relax. They were performing a task.
So the lesson there is, keep it simple, stupid,
Yeah.
especially when you're already stressed. Don't try to learn a complex choreography. Just breathe in and out.
That's the takeaway. Don't let the technique become another stressor.
So let's summarize the entire breathwork audit before we move on to the chemistry. To effectively hack the system. 1, slow it down.
Definitely. Below 20 breaths a minute.
2, do it for at least 5 minutes, no shortcuts.
Commit to the dose.
3, use a guide or an app, at least at first, to offload the thinking. 4, ensure you are physically comfortable so the signal can get through. And 5, keep the technique simple.
That is the formula for success, distilled from nearly 3,000 studies.
Okay, so that is the mechanical lever. We are physically manipulating the machinery of the body to send a signal to the brain. Now I want to pivot to the chemical lever. We are going to talk about oxytocin.
Let's do it. This is where it gets really cool.
Now, you dropped the bomb in the intro. You said we need to stop calling it the love hormone.
Yeah.
But that is how it's marketed everywhere. It's the cuddle chemical. It's what you get when you hug someone. It's in those nasal sprays they sell online.
It is. And that branding isn't entirely wrong, but it is dangerously incomplete. The source material for this section, the review by Triana Del Rio, goes deep into the molecular signaling. And the most accurate way to describe oxytocin isn't love. It's salience.
Salience. Okay, that's a term from signal processing or psychology. It means what? Importance, relevance.
Exactly. Think of your brain as a radar station. It is constantly being bombarded with thousands of signals, the noise of the air conditioner, the light from the window, the temperature, social cues from a person's face, internal feelings, potential threats. Most of it is just background static.
Okay, a sea of noise.
Right. Oxytocin acts like a signal booster. Or maybe a better metaphor is a spotlight. It shines a bright light on a specific signal and turns the volume on it up to 11. It dramatically improves the signal-to-noise ratio.
So it highlights what matters in any given moment.
It highlights what is contextually relevant. Now, in a safe, positive environment, like when you are breastfeeding a child or hugging a partner you trust, what is relevant?
The connection, the person's face,
Okay.
the feeling of safety.
Right. So oxytocin amplifies those social cues. It makes the bond feel profound. We interpret that feeling as love.
Okay, I'm with you so far. That makes sense.
But what if you are in a threatening environment? What if you are walking down a dark alley and you hear a branch snap behind you? What is relevant then?
The threat, the noise, the potential danger.
Exactly. So if you have a surge of oxytocin in that moment, it doesn't make you want to cuddle the potential mugger. It amplifies the salience of the threat. It makes the danger feel more real, more intense, and more memorable.
Whoa. So oxytocin can actually increase fear. You can pour gasoline on the fire.
It absolutely can. This is what we call the oxytocin paradox. And understanding this paradox explains some really confusing and contradictory clinical findings.
Like what? What kind of finding?
Well, for a while, researchers had this very linear thought. Hey, If oxytocin causes calm and bonding, let's give it as a nasal spray to people with PTSD or social anxiety. It will cure them.
Makes logical sense based on the old model.
But when they ran the trials, the results were all over the place. A mess. In some cases, it helped a little, but in others, patients given oxytocin actually showed increased attention to fearful faces in studies. They had more intense, intrusive memories of their trauma.
Because their brains were already tuned to the trauma channel, and the oxytocin just turned up the volume.
You nailed it. It cemented the salience of the trauma. So oxytocin is not a happy pill. It is a pay attention to what's important right now pill. And what's important depends entirely on the context.
That is a fundamental shift in how we have to think about this. So if we want to use oxytocin for calm, to our benefit, we have to make sure we are tuning it to the right station. We have to control the context.
Precisely. And to understand how to do that, we have to look at the wiring. We need to go into the limbic system.
Okay, put on your hard hats. We're going deep into the brain. Where do we start?
We start at the PVN, the paraventricular nucleus of the hypothalamus. This is the factory. This is where oxytocin is produced. When you are stressed or when you are connecting socially, the PVN pumps it out.
And where does it go from there?
It has a dual mechanism. It gets released into the bloodstream where it acts as a hormone throughout the body. But more importantly for our conversation, it also projects directly as a neuromodulator into other brain regions, especially the amygdala.
The fear center.
The fear center. Now, the review breaks down the amygdala in a way that is really specific and really cool. It's not just one big blob that lights up when you're scared. The key area is the central amygdala, or cell, and it acts like a switchboard.
Okay, visualize this switchboard for me.
Imagine two groups of neurons in there, and they're basically fighting for control of your fear response. Group one are the cell-on cells. These are the bad guys in our story. They express a marker called somatostatin. When these cells fire, they trigger the freeze response.
So somatostatin-positive cells equal freeze, passive fear, paralysis, the deer in the headlights.
You got it. Group two are the sell-off cells. They express a different marker called PKC delta. When these cells fire, they inhibit the on cells. They turn off the freeze response. They allow for active coping, for moving forward.
So PKC delta cells equal unfreeze. They break the paralysis and let you take action?
Exactly. It's a constant tug of war between these two cell populations. And here is the magic trick. Oxytocin specifically targets the off cells.
So oxytocin is the reinforcement for the good guys. It's the cavalry.
It binds to receptors on those PKC delta cells, it excites them, and that causes them to release GABA, which is the brain's main inhibitory neurotransmitter, onto the somatostatin cells.
So it tells the off cells to tell the on cells to shut up.
A perfect summary. It shuts down the fear response at the cellular level. Biologically, oxytocin is the switch that can move us from freeze to action.
But wait, hang on. You just told me 5 minutes ago that oxytocin can make fear worse. Now you're saying it turns the fear cells off. How do we reconcile those two things? They seem like total opposites.
This is the billion-dollar question, and this is where the concept of social buffering comes in. This is the crucial link that ties it all together.
Okay. Explain social buffering.
Humans are obligate social animals. We are not designed to regulate our stress in a vacuum. When we are with a conspecific, a friend, a partner, a trusted member of our tribe, that presence fundamentally changes the context of the stress.
Okay.
So when you are with a safe person, your brain releases oxytocin. But because the source of that release is social connection, the oxytocin activates the reward pathways at the same time. It talks to the ventral tegmental area, the VTA, and releases dopamine.
So you get a happy cocktail of oxytocin and dopamine.
Right, and that dopamine-oxytocin mix tells the amygdala, this is a social situation, we are safe. Turn off the freeze response. It directs the oxytocin to bind preferentially to those off cells, the PKC delta cells.
So the social context steers the chemical. It tells the oxytocin where to go and what to do.
Exactly. If you are alone and terrified, the oxytocin might just amplify the threat signals coming from your eyes and ears and turn on the freeze cells. But if you are holding someone's hand while you get bad news, the oxytocin amplifies the safety signal coming from that touch and turns on the cope cells.
That is profoundly beautiful, actually. It means we are biologically wired to need each other to be brave.
We're open-loop systems. We co-regulate each other. This is not a philosophical idea. It's a neurological fact.
This connects back to the breathwork study, doesn't it?
Yeah.
I'm starting to see the threads come together in a really powerful way.
It connects perfectly. Think about that human-guided training component we discussed.
Right. Why was having a guide so much more effective than doing it alone?
I would argue, based on this oxytocin research, that the guide acts as a form of social buffering.
Even if it's just a recording, a voice in an app.
Even if it's a recording. The human voice, especially a calm, rhythmic one, is an incredibly powerful social cue. It signals presence. It signals you are not alone in this.
So when I put on my headphones and listen to a breathing guide, I'm not just getting technical instruction on my breath. I'm actually hacking my social salience circuitry.
You are creating a social context of safety. You are telling your amygdala, we are doing this together. That directs the brain's own endogenous oxytocin to flip the switch from freeze to calm.
And then simultaneously, you are doing the slow breathing from the first study.
Which is the bottom-up signal. The diaphragm moves, the vagus nerve fires, and it sends a direct mechanical signal to the brainstem saying the body is safe, there is no tiger.
So you have the body saying safe from the bottom up via the breath, and the brain's social circuit saying safe from the top down via the guide and the oxytocin system.
And when those two signals meet, you get them a maximum reduction in allostatic load. You flip the switch with overwhelming force.
This is the integrated control panel. You can't just mash one button and hope for the best. You need to align the inputs for the system to work properly.
Correct. And if you try to do it in isolation, if you try to be the lone wolf, doing rapid breathing in a bathroom stall, you are fighting your own biology on multiple fronts.
You're fighting the oxytocin paradox.
You are. You're giving yourself a chemical that might just be amplifying your feeling of isolation and threat.
This has huge implications, so let's make this practical. I want to walk through a day in the life of a listener.
Yeah.
Let's call her Sarah. Sarah works a high-stress job, has kids. She's trying to keep it all together.
Okay, a very common scenario. Let's help Sarah out.
Scenario 1. It's 8:00 a.m. Sarah opens her email. There's a message from her boss with the subject line, "We need to talk." Her heart rate spikes. Her stomach drops. She enters the panic zone. What should she do based on the biology we just discussed?
Okay, her instinct will be to freeze. That's the somatostatin cells firing. Or to frantically start preparing for the worst, which is just pure sympathetic activation.
Right.
Step 1. She needs to stop and acknowledge the state she's in. Don't just power through it. Step 2. Do not just take 3 quick breaths. That's a waste of time. She needs to carve out 5 minutes. Go to a quiet conference room, her car, even the bathroom.
Okay, commit to the time.
Step 3. She needs an external regulator. She needs that social buffer. The best option, call her partner or a trusted work friend for 2 minutes just to say, hey, I got a scary email. Can you just listen for a second?
That triggers the social buffering oxytocin release.
Exactly. Or, if that's not possible, she puts on a 5-minute guided breathing track on her phone. That voice becomes the buffer. Step 4, she just follows the instructions and breathes slow, signals safety from the bottom up.
So the combination of the guide or the friend for the social context and the time and pace for the mechanical signal is the antidote.
It is. It primes her brain to handle that meeting not from a place of freeze, but from a place of cope. The PKC delta cells are now in charge.
Okay, brilliant. Scenario 2. It's 6:00 p.m. She's home. The day is over, but she's exhausted and wired. She can't unwind. She's scrolling social media on the couch while the TV is on.
This is the danger zone. Scrolling is interrupted attention. It's constant low-level salience spikes. Every new post is a micro-jolt for the brain.
And it's not restful.
It's the opposite of restful. The Oxytocin review mentions that things like protein synthesis are required for fear extinction. That's a fancy way of saying it. The brain needs downtime to actually build the new structures of calm. It needs to consolidate the safety memories.
And it can't do that if it's constantly being poked by notifications.
It can't. This brings me to a final thought I had about those outliers in the Breathwork study. You remember the study by Meyer?
The interruption study, yes.
Yes. In that study, the participants were doing the breathing correctly for a long enough time, but the researchers interrupted them repeatedly to ask, how stressed are you now on a scale of 1 to 10?
Right, for a survey.
And the intervention completely failed. It had no effect.
And I realized when I read that, that is our lives. We are all the participants in the Meyer study. We try to relax, but the phone pings. A new email comes in, the watch buzzes. How about now? Look at this. Respond to this.
That is a profound insight. The study shows that interruption effectively kills the biological benefit of the practice. It breaks the signal.
So we might be living in a state where our environment has made it biologically impossible for our natural stress reduction systems to kick in properly.
Because we never get the 5 minutes of uninterrupted signal required to cross the physiological threshold, we are constantly resetting the clock back to 0. Every ping is a reset.
That is genuinely chilling. The attention economy isn't just stealing our time and focus, it's breaking our biological ability to self-soothe.
It is keeping the cell-on cells firing. It keeps us in that low-grade free sphere loop.
So the ultimate biohack for Sarah at 6:00 p.m. isn't a fancy supplement or a meditation cushion. It's do not disturb mode.
It is the only way. You have to protect the container of time. You have to create a sanctuary from interruption.
5 minutes. Uninterrupted, guided, slow.
And preferably with a loved one or a pet nearby to boost that social safety signal even more.
Simple.
Okay.
Ancient. And backed by, what, 2,900 articles and a whole lot of molecular neuroscience?
The best solutions usually are. We just have to have the discipline to create the space for them to work.
Well, there you have it. The manual for your internal control panel. We hope this helps you navigate the frequency of the world a little better this week.
Absolutely. Knowledge is power, but applied knowledge is calm.
I love that. Thank you for helping us unpack the wiring today.
Always a pleasure.
And thank you for listening. Go find your 5 minutes. We'll see you on the next deep dive.